How's it going, everybody? This is Christina, and today I'm going to talk about hybrid multi-cloud event mesh and show you how I built one with Red Hat integration that includes Camel Quarkus, Camel K, and Camelot on top of OpenShift and also making it serverless. The whole reason why I'm doing this is because I'm seeing trend from our customers that our survey shows 69% of them are currently transforming or accelerating into their journeys towards being cloud native. And interesting enough, more than 50% of these customers has purchased SaaS service or packaged software and is working on integrating or composing these services and solutions for their enterprise. Clearly, the CTOs and architects today are looking for a fast, simple way to ramp up their services without sacrificing security, stabilities, and agilities. So one particular statistics has caught my attention. That is, most IT department has decided to deploy their applications on top or not to only one, but multiple or hybrid clouds. Well, here's why I think everybody is now adopting multi-cloud and why is it becoming more popular. Well, the first thought that comes to my mind is geolocations, right? You want your cluster to be closer to your business, wherever that was in the world, and maybe closer to a help center that your company just established. You want it to map your workload, and sometimes just expand geographical coverages. The second one would be more towards the governance side, right? Depending on where you are, countries has their own regulations, and sometimes company has internal policies enforced with different regions, some industrial specific rules, different supervisory nationally, and so you want them to be forced and apply into different cluster in different regions, not necessarily apply all of them in your data center or even your headquarters because it can get very complex. The other thing that I think is why driving everybody to multi-cloud is data gravities, right? So when you have data, it tends to be closer to where it's mostly heavily used. So you can avoid ingress and egress traffics. Sometimes it gets really difficult to just wire the data to the places that you want it to be, right? And the next one is IT agilities, right? You want to keep your options open. You don't want it to be locked in by a single vendors. And, having cross-cloud allows a lot better resiliency. Say if Amazon's down, you still have Azure, you still have Google to help you run your infrastructures. And the other one I can think of is better solutions offering. Sometimes some vendor just offers better services in terms of maybe IoTs, AML to your particular needs. So you have to run your workload on that cloud. That's why you have to be on the cloud that you want to deploy your applications on, but running it on a different cloud for that particular services. The last one I can think of is flexibilities, right? Again, no vendor lock-ins, and you can have better contingency plans. You can build up your exit plan if problems with current cloud, you can always move on to the next one. Or sometimes you just have that budget limitations where you want to deploy it into cheaper options and things like that, or you can bargain for a better price if you're not just locked in by the vendors. Of course, there will be challenges when you apply multi-cloud. You will be facing a lot more complexity, of course. Majority of the cloud vendors has their own proprietary technologies, and finding the scale staff that has experience with all cloud can be very difficult. And you also need to set up a holistic approach to all of the cloud for monitoring, configurations, and even automations. Security is another concern, right? Now data are more vulnerable since they are not protected behind the traditional heavy firewalls. There will be more traffics, so you need to secure the network, application, data storage, and that also introduces extra complexities. Data tends to be gravitate towards where it was used before, right? Like I said, and being able to easily propagate without overflowing the ingress and egress, because honestly, ingress egress traffic costs money, and making sure that they are consistent across the cloud can be also challenging. Remember from the previous surveys that 54% of the company also needs to interact with other SaaS or packaged softwares. So connecting the dots is going to be difficult too. And this is the topic I want to dive into this time. And this is what this demo is trying to solve. There are three common problems, and that's why we need a proper connection strategies for multi-cloud solutions. Service silo is one of them, where the services are deployed to the cluster that the teams or development teams are more familiar with. So it is impossible to discover and even to reuse them when you don't even know they exist. So a secure and simple way to get your data and services is extremely important. Another one is data integrity. Well, I don't think I need to explain how important it is to keep data real-time and in sync. Last one, I don't really hear many people talking about it, but it is definitely going to affect how fast to deliver changes for your applications, and having too many point-to-point connections would lead to integration mess. In the perfect world, I would have everything unified, a monitoring, governing cloud with consolidated view and methods, right? And managing clusters, automating deployments, and just some day-to-day operations with an abstraction layer that will then convert to each specific cloud technology. So all the layers are secured with compliance scans on different cloud technologies. Developer will be choosing the technology that fits them best, where cloud will be transparent to them. They don't even have to know what cloud they're on. The applications can be pulled and plugged into another cluster easily. And there will be an easier way to discover and talk to the services. Data are always in sync with a unified protocol. But we all know that will not be the case, right? Many companies would found themselves going into single cloud, and due to many different reasons, such as different departments decided to use different providers, or Google just happens to have that service that they absolutely needed. The other one probably need the applications on AWS, or you kind of just happen to acquire another company, and suddenly you find getting data and making real-time transactions gets really complicated. And to be frank, who doesn't have that legacy system that sits behind back home, and where you need to integrate with all this, SaaS services or handling tickets on a CRM, for instance, right? So this is kind of a quick view of what it's going to look like. My proposal to avoid these spaghetti situations is to build an event mesh for your hybrid multi-cloud. By deploying Kafka on top of OpenShift, we have a streaming backbone to have the capacity to accept sudden bursts of events and data. And with Camel connectors, we have all the protocols needed to receive and send events to almost anything to any cloud. Having all the events flowing through event mesh in real time optimized and minimize the ingress and egress traffic with proper orchestrations and transformations for better performance and cost. We will have a unified view of how the mesh is performing, scaling up and down as needed, and even take it further by introducing serverless for on-demand resource usage. Turn off part of the mesh when there's no longer needed, and also provide topics and channels so others can reuse services by piping data into it. And to integrate with other SaaS applications, I'm going to collect incident tickets from a popular IT service management cloud platform, Servicenow, where user will be using it to create incident tickets and ask services on AWS, Azure, and Google Cloud Platform to perform what is needed. First, we'll create a backbone for my mesh. The self-service allows me to create Kafka cluster to stream the unprocessed events. Then I'm going to start a service that collects data from Servicenow, and while collecting the events or the incident tickets, I will filter and transform the data into smaller payload. The payload is then picked up by other subscribers of the mesh, and depending on the destination cloud, it will make custom updates to the payload and establish a connections to each protocols to the mesh, such as to AWS, Azure, and Google Cloud Platform. So we can then send tickets, the incident ticket with minimized payload, to Azure, to their Event Hub for data poolings, and Service Bus to trigger a Azure functions. And for AWS, we will be broadcasting the events to SNS, and it will then pick up by one of the functions on Lambda, and then eventually gets to SQS for further usage. Lastly, the events to the Google will be using the PubSub functionalities. And again, these events will then be picked up by a cloud functions on Google Cloud Platform, which will then perform whatever is needed on Google Cloud. Then we will be using a serverless connectors, their Camlets, to subscribe from each cloud for any result, and will provide notifications to the users. When the event results comes back, our serverless functions will then scale up and then return the result back to our notification channel. In this case, will be Telegram. Alrighty, let's go ahead and take a look at the actual demo. And this is Servicenow, the IT service management system, very popular among different companies. And we're gonna use it to create our incident ticket to submit whatever action the user requests to our multi-cloud system, right? And here I'm just gonna fill in the request I wanted to perform on my Google Cloud Platform, and this will then relay to the Google Cloud Platform through my event mesh. So once the ticket's created, you can see now it's going to, I specifically mentioned it to go to Google Cloud Platform. And let's take a look at the system. Now it's been picked up by my system, and then it's been sent to Google, and it came back with the result to my Telegram. Now let's take a look at the Google console. The Google console here shows the pops up functionalities. As you can see, the events has been transferred and delivered to the Google Cloud Platform, and also being picked up by one of the functions that I have set up in the platform, which is listening to the pops up event. And let's go take a look at the log. As you can see, the event has been published to the Google Cloud with all the contents needed. So how's this done? Well, the first thing is I have a Camel Quarkus application that does a little bit of orchestrations and transformation of the data to make the payload smaller, and then it's being sent to Kafka as the streamings, and then being sent to Google, and once Google perform, it comes back to Kafka, and then it's picked up by my serverless application, and notifications get sent to Telegram. Well, the next one is another incident report that I want to create. Then this time I wanted to send it to Azure. So same as before, I'm going to enter the content, and the data would then the event will then publish to Azure, and it will come back with the result as well. So through my mesh, everything at the events has been published to two different places. The first one is another streaming platform by Azure EventHub. As you can see now from the console, the dash console, you can see the events has been populated here as well. Another place that I have sent is the service bus, which is connected to Azure function. The Azure function will then listen to any events that was sent into the service bus, and then trigger the function that will perform anything that I wanted to do on the Azure cloud. As you can see now, the events has come in, and the result has been published back to my services, and that's how it's done. So similar to before, it was picked up by the same Quarkus, Camel Quarkus applications, and then being picked up from streams and sent to two different places in Azure, and then the results has come back to our serverless applications, and eventually end up in Telegram, which is showing us the result. The last one is the mesh going to AWS. So similar as the previous times, where this time I'm going to send it to AWS, and this time I'm going to send it to one of the services on SNS services on AWS. So you can see that the data has come back with a little bit of different payload. So this is what it looks like in AWS, and then this is and then another Lambda function was triggered when it's published to the SNS. And let's take a look at the log here, where this function is performing some sort of actions, of course. As you can see, the payload is actually coming from what we've just sent to it, with the payload saying the content of what we wanted to perform in AWS, and with the same incident ID. So similar to the previous scenarios on this event mesh, I'm collecting tickets from Servicenow using a Camel Quarkus application doing some kind of orchestrations. And then I'm going to publish the events to AWS SNS, and the results was collected by a Camelot that listens to the SQS from the results, and then eventually data came back in as a serverless application. So looking at the last one, I'm sending a RESTful call into the mesh, and this will also populate the events into the mesh and to the multi-cloud platform, and also get the result back to the Telegram. And this is also done through the event mesh, but receiving a RESTful service call with the serverless applications, and it also gets populated to the streaming real-time platform, and then the events gets pushed into several different clouds. The results came back in the same way as well. And as with the event mesh, what I can do is I can also view the performance and what's going on with the entire mesh. So I have a consolidated holistic view of what's going on with the mesh and which is not working. So I'm just going to go ahead and then point to a specific time where I have a lot more events going on. As you can see, I can see failures, in-flights, camel routes, who is running, and CPUs and memory usage across different clouds. So I want to dive in a little bit deeper on the experience the developer would have to build this event mesh using Red Hat integration. We're going to start by laying the foundation, which is creating the streaming backbone. We're going to use Kafka clusters and topics to handle all the high volume of throughput of events. So we're going to go ahead and create using our self-service capabilities on OpenShift platform, where we can easily start up a cluster, and this cluster will now handle all the events. And once we have all the foundations, and then we can work on connecting the dots for our service mesh, right? Building the mesh itself. So there's several different ways we can do it. We can either use microservices using a function or using a event source connector. So for microservices, so these are the application that runs on top of your, or these are the connectivity applications that helps you and runs on your platform 24/7. So I created a Camel Quarkus application, which is running on a super lightweight runtime, but it creates a lot of things, right? It connects. So first of all, it connects to the real-time streaming platform using a simple, very easy to tell DSL. So here I'm just indicating that I'm going to a particular topic incident all to a Kafka topic, obviously with some kind of configurations. And another one is accessing to the protocols. So I can use any microservices or any Camel Quarkus application to all the different destinations that's available, right? So I can connect to Servicenow. I was able to connect to Google pops up, and I was connecting to Azure. So all these protocols are taken care of for me, and all I need to do is just specify where to go and just giving it some of the credentials and all that kind of stuff, and also doing some kind of orchestration. So in the event mesh, sometimes we need to broadcast the events into several different places at the same time. As you can see, I have a parallel processing. That means that I'm publishing the events to two different places simultaneously. Or sometimes I need to work on the payload and make it smaller, or make it understandable for other subscriber to the mesh. So therefore I need to do some kind of splitting of the informations. Another thing that I did in the this microservices is the transforming the actual data. So there's many different ways I can transform with the Camel Quarkus or Camel K. As you can see that I'm using a Marshall to JSON. So that means that I can turn my data into many different types of data, right? I can turn it into JSON, XML, whatever that was. And the other beautiful thing about Camel is the ability to support toolings. Here I'm showing you a tooling LS map. So this allows you to do drag and drop mapping between field of your data. So you can turn that, so it's more obvious and visual to developers. So that will be easier for them to map everything. And you can easily plug it into your application. So your application will automatically turn the entire payload into something that you understand. And also, another thing that people often ask is, once you have all these microservices, what are you gonna do when you have different secrets or different password to, in different environments? Say you have productions, testing stagings, all that kind of stuff. So I have created a couple of different secrets and configurations that is on top of my platform in that specific namespace. And I'm actually pointing to those secrets in my application without specifying the actual credentials, so that if I change namespace or change environment, all I need to do is just change the configuration in the actual platform. And then it would apply to it. So I have the security done and I have the portability as well. So another thing I want to talk about is deployment, right? A lot of times packaging my applications into cloud or making into containers is confusing. But again, I can easily deploy my applications into the cloud with a single Maven command. So there's other ways I can do it through CI/CD pipeline, but it's another big topic. I will discuss that later maybe in the future topics. So another way of connecting the dot is function. So this type of application are generally smaller, less complex. They are form of couple of lines, very small code base where they're doing simple stuff. And the way that developer works with this kind of functions is that they will be working directly in the environment. They want to see the result immediately for testing. So that's what this is for, and I am using Camel K as well as Knative together in order to achieve this. So now in functions, there's several different things we cannot sacrifice, of course, because we're connecting the dots. That's the most foundation thing for event mesh, and therefore we still have to have all the protocol available to us so that we can start connecting. And then we also want to do being able to do a real-time streaming, being able to access those events, populating the events, and orchestrating the events, of course, and then transforming the data in the events as well. They are similar to what I've just said in the microservices, so I'm not going to repeat again. But also the credentials and configurations and certificates, the things that you need, and can also be separated as a different deployment, and your functions can connect it to it later. The other thing that's really cool about the functions is the ability to do hot reload on the cloud. So whenever I code, I would see that immediately reflect on the container and on the cloud. So it's an immediate feedback to the actual deployment platform. The other thing is we don't want to spend a lot of time building the project, so there's no compile. Everything is done automatically and instantaneously. So all the dependencies that you need are automatically loaded and detected, so you don't have to do all the compiling yourself. And also some part of the life cycle of the functions are taken care of you. Speaking of scaling down to zero, one of the other things about function is the ability for it to scale down to zero and to scale out when you need it, and the ability to handle cloud events, because cloud events obviously are used a lot in the eventing, especially when we're creating event mesh. So it's especially important when you're dealing with event mesh. So cloud event is the CNCF Cloud Foundation's recommendations for transmitting your events through the cloud. So we also support that, as well as creating channels and broker to persist or to deliver these events. And last but not least, is something that's new. It's I call it event source connectors, but they have another names in community called Camelot. So these are the things that typically that's more for people that's not familiar with coding, but they just want to connect the dots in the mesh. So all they want to do is just to move stuff from one point to the other. Maybe they want to reuse some of the previously built connectors. So these are the people that uses it. So a very important thing is that you would have a catalog of connectors for these people to choose from, so they would be they would have free access to all these different connectors, and they were able to deliver the events from one point to the other in the mesh. And then this is template based. So if you don't find anything available, or if there's any specific things that you need to build for your company, you will be able to do that through the templates. And here I'm just showing you a quick template of how this is done. And also I have a user interface, which is another one that's available for pure connector. You have a very nice user interface to configure where how everything is going, something like the credentials, and it will immediately turn this configuration into a running process or a running pod on top of your cloud. So this is an overview of how my developer actually works to create this mesh. First of all, we have so I've talked about it. We have a foundation, and then we're gonna go ahead and create microservices, as well as self-service myself to create channels to start hosting cloud events for my serverless applications. And then I can create functions that will save you a lot of resource that would be for your resource optimizations, and then a lot of event sources to do the connectors. And basically that's how I build the connectors. I have more videos coming up, maybe dive into the code and how each code works. If you're interested, just make sure that you subscribe to my channel, and I'll talk to you next time. Thank you.